In this lecture, we are going to discuss types of image transformation. And in our previous lecture, we have already discussed what is image transformation and why it is important. So there are two types of image transformation. First is Fourier transformation and second is discrete cosine transformation. And first we discuss what is Fourier transformation. So Fourier transformation is a simplest technique in which edges of an image can be found. So Fourier transformation mainly used for image processing, and in FT the intensity of image is transformed into frequency variation and then into the frequency domain. It is used for slow varying intensity images such as background of a passport size photo can be represented as low frequency component and the edges can be represented as a high frequency component. So the component of an image is in the form of low frequency and the edges of the component of an image is in high frequency. So low frequency component can be removed using filter of Fourier transform domain. When an image is filtered in FT domain, it contains only the edges of the image. And if we do inverse FT domain to special domain on XY, then also an image contain only edges. So Fourier transformation is a technique that used to make the edges of an image in a fine form. So what are the properties of Fourier transform? Symmetric unitary, periodic extension, sampled Fourier, fast, conjugate symmetry, and circular convolution. These are all the properties of Fourier transformation. Here we have an example. In this we have a passport size photo, and after performing Fourier transformation we get an image in this form, and we can see the edges of the image is in a fine form. So this is the example of Fourier transformation. Next is discrete cosine transformation. Discrete cosine transformation used for lossy compression, and in this the information related to the pixel of an image stored in the coefficients. So in DCT, coefficient carry information about the pixel of image. Also, much information is contained using very few coefficients, and the remaining coefficient contain minimal information. These coefficient can be removed without losing information, and by doing this process, the file size is reduced in the DCT domain. DCT is also used for lossy compression. So what are the properties of DCT? First is real and orthogonal. C is equal to C steric implies C minus 1 is equal to CT. And second is not real part of DFT. Third is we get a fast transformation. Last is excellent energy compaction. So these are all the properties of DCT. Next we have an example. This image is in a digital form, and after converted it into the DCT domain, it is in this form. So what is the application of image transformation? As we know, we have two types of image transformation. First is Fourier transform and second is discrete cosine transform. So first, Fourier transform used for edge detection, means for edge to make the edge in a fine form, and it work on the edges of the image. And second is discrete cosine transform, and it is used for image compression, means it is used to reduce the size of any file. So thank you for today. I hope you get it, and if you have any doubt, please ask in the comment box.